We're continuing now with step 5. We're going to look at the second derivative, and we're going to glean all that we can. So y prime is going to be, well, it's f prime g, so f prime is 20, and g is x squared minus 4 squared. And minus f, which is 20x, g prime, which is 2 times x squared minus 4 times 2x, and it's over g squared, x squared minus 4 now to the fourth. So just to label what we did here, the 20 is my f prime, this here is my g, the 20, oops, oh, I left an x out. The 20x is my f, and this whole thing here is my g prime, and that's the outer, and that's the inner of the chain rule. Anyways, and this of course here is g squared. That's the easier part. Let's simplify this a little bit. Now, y prime, y double prime, and again, even though I said, sometimes if I just wanted, even though I gave you the whole speech, how you don't have to necessarily simplify, but for a problem like this, you want to simplify because you're going to want to see when it's positive, when it's negative. It's much easier to work with when it's simplified. Anyway, there's a 20 times x squared minus 4 on in both of these terms. So I could factor out 20 times x squared minus 4. And I have in here, what's left, I have x squared minus 4 minus, let's see, I took it at 20, minus 4x squared over x squared minus 4 to the fourth. And notice that this x squared minus 4 cancels out one of those. That becomes a 3. So now I finally have y double prime equals negative 20 times 3x squared plus 4 over x squared minus 4 to the third power. Now this part over here, let's look at y prime table here. So when does this equal 0? When is it undefined? Well, it never equals 0 because 3x squared plus 4 is always a positive number. Since that's a perfect square. So this never is going to equal 0. But the bottom could equal 0. So I could have, so y prime is undefined, at x equals plus or minus 2. So I'm going to make a negative 2 and a positive 2, and we're gonna test some points here. So let's test. We have 0 as a nice test point, and I guess I'll test, I don't know, 3 and negative 3. Those will be my test points. Okay, let's do it. So we're going to put that into y prime. So negative 20 times 3 times negative 3 squared plus 4 over negative 3 squared minus 4 cubed. That was loads of fun. And let's see what that is here. So that is negative 20 times positive 27 plus 4, which is 31. And this is going to be, that's going to be 9, positive 9 minus 4, which is 5 to the third power is 125. Anyway, bottom line, it's a negative number. And 0, we have negative 20 times 0 plus 4 over 0 minus 4 to the third power. And this is going to be a, let's see, it's going to be negative 80 over negative 64, which is a positive number. That's all I really care about, it's a positive number. So obviously we have concave down, and that's obviously concave up. And for x equals 3, I have negative 20 times 3 squared plus 4 over 3 squared minus 4 to the third power, which actually winds up being the exact same number that I got over here, negative, negative 20 times 31 over positive 125, which is negative. So our function is concave down. And now I would love to say that I have points of inflection at -2 and +2, but I can't because they're not part of the domain of the function, as we mentioned previously. So again, there are no points of no POIs here, no POIs. Sorry. And let's kind of put together everything we have here. Let's kind of see if we can put it all together a little bit. So we know we have a horizontal asymptote at y equals 2. And we know we have a vertical asymptote at x equals plus or minus 2. We know we have a min at 0. Oops, I'm sorry. That's 2. We know we have a min at 0, 9 halves. And we have a vertical asymptote. This is probably just going to go up. This looks like it's just going to go up to that min. Here we have an asymptote and now another asymptote. When does it hit the x-axis? It hits the x-axis at -3, but that's 3, and that's -3. So it looks like it's going to be something like that. Notice it's concave down on in the ends, concave up in the middle. Notice that it's decreasing. It's decreasing up to the 0, and then here it's increasing, because this is decreasing. It jumps up there, but it's still decreasing. And then on the other side of the axis, it's increasing. It jumps down, but it's still increasing. So it's increasing everywhere. This is the only min. There's no points of inflection. We got the concave up, concave down. It looks pretty good. I think what we have here looks pretty nice. Let's go to Desmos and see if we can. Let's go to Desmos and see if we can, you know, type it in there. See if what Desmos gets is similar to close to what we got. Hopefully it will be. Okay, so I have to click my switch cameras now, and I want to share my screen. And now we're in Desmos. Let's type this in, make it out of the way. Let's type this into Desmos. So it's y. Again, we're typing in the original function, y equals 2 times x squared minus 9. And that's going to be over x squared minus 4. Oh, look at that. Wow. Now let's type in those asymptotes. X equals 2, x equals -2. Look at those nice, beautiful asymptotes. And y equals 2. That is some beautiful asymptotes right there. And let's make the asymptotes dotted so you can tell. And there you go. And this is our min right there. Our x-intercept is +3 and -3. 4.5 is 9/2. That's our y-intercept and it's our min. Here's our asymptotes. Everything is beautiful. Notice that it's concave down. It's exactly the way we drew the way we drew it. So let me I'm actually gonna take a screenshot of it. And panel, we're good to go. Well, everybody, it's been loads of fun. Hope you enjoyed this as much as I did, and we will see you guys next time. Bye.